Want to know how to choose the right thickness for color-coded plates? Let's dive in and unlock the secrets to mastering the selection of color-coded sheet thickness. First, let's talk about choosing the thickness based on the application scenario. From a microscopic perspective, the coating of color-coded plates contains corrosive media in the air, like water and chloride ions, can penetrate through these micropores or scratches in the coating, leading to underfilm corrosion, which causes blistering and peeling of the coating. Therefore, the coating thickness shouldn't be underestimated. Generally, a thicker coating acts like heavier armor for the color-coded plate, more effectively blocking the attack of moisture and corrosive agents. However, we also need to consider the cost-effectiveness. For coatings like PE polyester, HDP high weatherability polyester, and SMP siliconized polyester, the combined thickness of the top coat and primer is preferably greater than or equal to 20 micrometers. For PVDF fluorocarbon coatings, the combined top coat and primer thickness should be greater than or equal to 25 micrometers. The backside epoxy coating thickness should be greater than or equal to 5 micrometers. If the indoor use environment is highly corrosive, a double coat on the back is recommended, with a thickness preferably greater than or equal to 10 micrometers or even thicker in severely corrosive environments. Appropriately increasing the coating thickness can significantly extend the service life of the color-coded plate. Next, let's discuss selection based on purlin spacing. When building a color steel shed, purlin spacing is a key factor. Purlin spacing should be set according to the model and thickness of the color steel sheet, generally between 700 to 1000 millimeters. However, this isn't fixed. Adjustments should be made based on the local climate. For example, in areas with heavy snowfall, purlin spacing should be appropriately closer together to prevent the sheets from deforming under the weight of the snow. Now, let's talk about factors influencing the thickness selection of color-coded plates. The thickness of the coating significantly affects the corrosion resistance at the cut edges of color-coded steel sheets. Cuttage corrosion is a type of electrochemical corrosion. While the pre-treatment layer and primer are relatively constant under normal conditions, the base metal thickness and coating thickness play important roles in cut-edge corrosion resistance. Simply put, a thinner base metal and a thicker coating generally lead to better corrosion resistance at the cut edges of the color-coded plate. An internationally recognized indicator is the zinc-tooth thickness ratio, which is the grams per square meter of the coating weight per side divided by the thickness of the base metal. When this ratio is greater than or equal to 100, it can effectively prevent cut-edge corrosion in color-coded steel sheets. For example, for a 0.5 mm steel sheet, the single-side zinc coating should reach at least 50 grams per square meter. For 0.6 mm, 60 grams per square meter, 60 grams per square meter, and for 0.8 mm, 80 克每平方米. Finally, a word on practical application. Some might wonder why it's often emphasized that the coating thickness of color-coded plates should be greater than or equal to 20 micrometers. In fact, experimental data confirms that when the front coating thickness is greater than or equal to 20 micrometers, it can effectively isolate corrosive media. As a source factory for color-coded plates, the recommendation is made considering durability and corrosion prevention for the user's benefit. In summary, selecting the right thickness for color-coded sheets isn't a simple task. It requires comprehensive consideration of various factors like the application scenario, purlin spacing, and other influencing conditions. Hope this sharing helps you feel more confident when selecting the thickness of your color-coded plates and easily choose the most suitable one